Hello students, in this video we will continue from where we have left in the previous class. So here we will understand discovery of nucleus. So in the previous classes we have understood how the electrons and protons were discovered by discharge tube experiment by various scientists, but the neutrons were not discovered until that. So neutrons was discovered by James Chadwick in the year 1932. Okay, and how it was discovered, let us understand that. Okay, so what did the theory which was given by scientist Chadwick, that is postulates of Chadwick's theory. Okay, so now since electrons have negligible mass, the mass of the atom, that is atomic mass, should be equal to the mass of the protons. However, in the case of helium, which has 2 protons in its nucleus, the atomic mass was not equal to the mass of the protons. So what was the conclusion? The conclusion is that it was therefore proved that in nucleus of the atom are present particles which have no charge but mass almost equal to the mass of the proton. Okay, like this the neutrons were discovered. So now let us understand in a simple language. Okay, now imagine that this is an atom. This is an atom. Now when the mass of the atom was measured, it was around 4 gram. So what was the mass of the atom? It was around 4 gram. Let us assume that the mass of the atom is 4 gram. But when we calculated the mass of the protons, we know that the protons are present. So mass of the proton is only 0.1 gram. So mass of the proton is 0.1 gram, but mass of the atom is 4 gram. So from that, scientists thought that there might be some other particles which are also having mass, but they don't have any charge. Okay, let us understand one more example. You can take one more example. Imagine that you are traveling and your father is carrying the luggage. Then most of the time what happens? Your father asks that, suppose this is the luggage which your father is carrying, and that luggage is looking like a very small one, but its weight is around 15 kg. Then what your father will ask? Your father will ask that how so much weight? How it's so much weight? What you've kept inside the bag? Then your mother says, I don't know, I have just kept the clothes. That means by the size it is looking lighter, but when we are lifting it, its weight is very high. Like that, similar to like that atom also. Here the atom of the mass of the protons are just very less, but the mass of the whole atom is very high. So from that, scientists concluded that there must be some other particles which are having masses but no charge, and in this way the neutrons were discovered. Now let us see how the nucleus was discovered. Okay, so how it was discovered that the electrons are rotating around the nucleus. So this was discovered by scientist Bohr in the year 1940, and he discovered the location and mode of rotation of electrons around the nucleus. So we have to understand what is Bohr's atomic theory. So Bohr's atomic says that electrons revolve around the nucleus in fixed orbits called energy levels, and those levels are numbered as 1, 2, 3, and they are represented as KLMN. Okay, now electrons rotate around the nucleus in one or more energy levels. So what does this mean? It's saying that Bohr's atomic theory says that suppose this is the nucleus, and around the nucleus, inside the nucleus what is present? Proton is present and neutron is present. But around the nucleus, so this is our nucleus. Now around the nucleus what is rotating? Electrons are rotating, and electrons are rotating in a particular shell. This shell is called as energy level. These are called as what? Energy level, and there are various energy levels. Okay, and each energy level is given as name. Suppose the first one is called as K, second one will be called as L, and similarly the third one will be called as M energy level. So these are various energy levels in which the electrons rotate. Okay, so now we'll see what does an atom contains. So atom contains a subatomic particle. First of all, what is those? The subatomic particles are protons, neutrons and electrons. Then it contains nucleus. So what is the nucleus? Nucleus is the central part of the atom. Remember, what is nucleus? It is the central region of the atom. Okay. Next, orbits or shells means the electrons revolve around the nucleus in imaginary paths is called as shells or orbit. That means around the nucleus, how the electrons are revolved, those paths are called as shells or orbits. Okay, this is the nucleus and these are the shells and orbits. Okay, here also the diagram is given, you can go through it. Now you have to remember that students, protons are having positive charge and unit mass. That means they will be having +1 charge and their mass will be unit, that is 1. But neutron will be having no charge, that means they are neutral. No charge means they are neutral, neither positive nor negative. But they are also having unit mass, that means their mass will be 1. Next, electron. They are also subatomic particles, but they are having negative charge, that is -1 charge. Okay, proton are having +1 charge, electrons are having -1 charge, but they are having negligible mass, means very less, equivalent to 0. So we can say that it doesn't have any mass, it's very less mass. Okay, so now let us see what is a periodic table. So what is a periodic table? Periodic table is a systematically arranged elements. The table in which the elements are systematically arranged are called as periodic table. So in class 8 you have to just remember this periodic table. Okay, so this is our atomic number 1 hydrogen, then atomic number 2 helium, then atomic number 3 lithium, atomic number 4 beryllium, atomic number 5 boron, atomic number 6 carbon, atomic number 7 nitrogen, atomic number 8 oxygen, atomic number 9 fluorine, and atomic number 10 neon. Now you have to remember this, that atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to practice this periodic table. Remember, you have to practice this periodic table, okay, as it is given in the table. Next we will see our atomic number. So what is an atomic number? So atomic number is nothing but it is the number of protons in the atom of an element. So how many protons are there, that will be the atomic number of that element. Okay, so remember that atomic number is nothing but the number of protons, and in an electrically neutral atom, neutral means if an atom is having no charge, that means the number of proton and number of electrons are having same. So remember that atomic number is given with the symbol Z. Z is the symbol of atomic number, which is equal to the number of protons, symbol is P, and which will be equal to number of electrons, symbol will be E. Will you remember that? Next let us see what is mass number of an element. So mass number of an element is the total number of protons and neutrons in the atom of an element. So in an element, how many total number of protons and neutrons are there? That will be equal to the mass number. So here you can see mass number is given the symbol A, which will be equal to number of protons P plus number of neutrons N. Okay, so remember here one plus sign is given, that means total number of protons and neutrons. So now how we can know the number of protons and neutrons? Here you see, for the case of hydrogen, atomic number, so this is our mass number and this is our atomic number. So atomic number is how many? 1. Sorry, mass number is 1, atomic number also 1. So since the atomic number is 1 and that is equal to protons and electrons, so we can say that how many protons and electrons are there? 1 proton and electron. Then mass number is also 1. So proton plus neutron is 1. So what will be neutron? Neutron will be equal to mass number minus atomic number, that is 0. Okay, so remember that number of neutrons, you can note down in your book, number of neutrons will be equal to mass number minus atomic number. Mass number minus atomic number. Let us take the example of carbon. In carbon also, the mass number is 12 and atomic number is 6. So number of protons will be how many? See, atomic number is nothing but equal to proton equal to electron. So atomic number is 6. So number of proton also 6 and number of electron also 6. Now mass number is how many? Mass number is given 12 here. So it will be 12. So proton plus neutron will be equal to 12. So now number of neutrons will be how many? Mass number minus atomic number. So 12 minus 6 will be equal to 6. Clear? So now we will see what is relative atomic weight. So what is relative atomic weight? So mass of an atom determined by the indirect method is to be very small. Okay? So we find out relative atomic weight. So let us take an example. So now you see atoms are very small, so you cannot take the exact weight. So what we do, we compare the atom of a particular atom with the atom of hydrogen or carbon. Okay. So here, to measure the weight of a particular atom, it is compared with either a atom of hydrogen or with a atom of carbon. So what is relative atomic mass? So relative atomic mass is nothing but the comparison. Okay, so it is the number of times one atom of an element is heavier than the mass of an atom of hydrogen, or also we can write number of times one atom of an element is heavier than 1/12 the mass of atom of a carbon. So we can write any one. Okay, let us understand. Now imagine that whenever we go to purchase vegetable in the market, what you can see, the vegetable seller uses a balance. This is called as a physical balance, right? Now one side he keep what? He keep the vegetables, right? And in the another side he keeps what? He keeps a 1 kg weight. Now what he is doing, he is just comparing the vegetables with 1 kg. Similarly here, the weight of the atom, suppose this is our atom, is compared with either one carbon atom, 1/12 of carbon atom, or it is compared with one hydrogen atom. Is it clear now? Similarly, we can also measure the weight of the molecule. So let us see what is molecular weight, relative molecular mass. So the relative molecular mass is equal to the number of times one molecule of the substance is heavier than the mass of an atom of hydrogen, or number of times one molecule of substance is heavier than 1/12 the mass of an atom of carbon. Similarly here also the weight of a molecule is measured by comparing it with one atom of hydrogen or 1/12 of an. Similarly here what we do, we take molecule, one molecule, okay, and then here we take either one hydrogen atom or we take 1/12 of one carbon atom. Like this we compare the mass. This is called relative molecular mass. Next we will see what is electronic configuration. So electronic configuration is nothing but the distribution of electrons in an atom. How the electrons are distributed. As we know that the first shell is known as what? It is known as K. Second shell is known as L. Third one is known as M, and the fourth shell is called as N, and so on. So remember here the rule which is used is 2n square. So what is 2n square? It is the maximum number of electrons in each shell. So in K shell, that is the first shell. So K shell is the first shell. How many electrons can be applied? 2 into 1 square. 2 into 1 square. Why? Here n is nothing but 1. So 2 into 1 square, that is 2. In the L shell, that is second shell, what will be the number of electrons? 2 into 2 square, that means 8 electrons can be occupied. This is the maximum number. Minimum whatever may be, but maximum 8 electrons. Similarly for the third shell, M cell, so number of maximum electrons are 2 into 3 square, that is 18 electrons can be occupied in the third shell. So here n is equal to 2 and here n is equal to 3. So everywhere we will apply 2n square to know the number of maximum electrons. So similarly now we will apply the same rule and we will find the electronic configuration of various elements. So first we will take sodium atom. In case of sodium atom, what is the atomic number? You see the atomic number is 11. So number of protons will be 11 and number of neutrons are 12. So number of electron also 11. So now in the first shell 2 electrons, in the second shell how many are remaining? Out of 11 2 are completed, so 9 is remaining. So 9 will be there in the second shell? No, this is wrong. Why? Because first shell capacity is 2, second shell capacity is 8. So remaining how many? 1, that will be in the third shell. Clear? So what is the configuration of sodium atom? 2, 8, 1. Similarly, what is the configuration of calcium atom? Its atomic number is 20. So number of electrons will be 20. So in the first shell 2 electron, second shell 8 electron, third shell also 8 and fourth shell 2. Next is isotopes. So what are isotopes? So isotopes are the atoms of the same element having the same atomic number but different mass number. So what are isotopes? Isotopes are the atoms of same element having same atomic number but different mass number. Let us take an example. So here you see the example is hydrogen 1, hydrogen 2 and hydrogen 3. They all comes from hydrogen. So they come from same element. Okay. Now their atomic number you see. Here also atomic number 1, here also atomic number 1 and here also atomic number 1. That means they are having same atomic number. But let us check their mass number. Mass number here 1, here 2 and here mass number is 3. So they are having different mass number. So all these three are called as isotopes of hydrogen. Clear? So now we'll see the electronic configuration of various atoms. So atomic number hydrogen configuration is 1. Okay. So here the configuration will be 1. Next atomic number 2 electronic configuration is 2. Atomic number 3 lithium configuration is 2, 1. Beryllium 2, 2. Okay. Boron 2, 3. Carbon 2, 4. Nitrogen 2, 5. Oxygen 2, 6. Then fluorine 2, 7. Neon 2, 8. Sodium 2, 8, 1. Magnesium 2, 8, 2. Aluminium 2, 8, 3. Silicon 2, 8, 4. Phosphorus 2, 8, 5. Sulfur 2, 8, 6. Then chlorine 2, 8, 7. Argon 2, 8, 8. Potassium 2, 8, 1. And calcium 2, 8, 2. So these are the configuration of various elements. You have to practice this configuration. Now here it is given in the form of a table. You can practice this table also, and here the valency is also given. Okay. Now we will see what is a valency. So valency is the number of hydrogen atoms which can combine with one atom of the element or radical forming a compound. Okay. So now what is a valency? So we have to remember that one atom of a hydrogen combines with one atom of chlorine. So valency of chlorine will be 1. Now in case of HCl, valency of chlorine is 1. In case of water, since 2 atoms of hydrogen combine with 1 atom of oxygen, so the valency of oxygen will be 2. So now there is a different definition of valency. Valency is also the number of electron donated or accepted by an atom so as to achieve stable electronic configuration of the nearest noble gas. That means number of electrons donated or number of electrons accepted will be called as valency. Okay. So now let us see what are metals. So metals are those atoms having 1, 2 or 3 electrons in their outermost shell, and they always lose or donate 1, 2 or 3 electrons to become positively charged ions called as cations. Okay. So now here you see sodium, its configuration is 2, 8, 1. So it loses 1 electron and becomes 2, 8. So it gets a positive charge. Hence it is a sodium ion. Next magnesium configuration is 2, 8, 2. It loses 2 electron and form Mg2 plus ion. Configuration will be 2, 8. Aluminium configuration is 2, 8, 3. It loses 3 electrons and form Al3 plus ions. Now let us see, to achieve stable electronic configuration, nonmetals generally have 5, 6 or 7 electrons, so they accept or gain electrons. to become negatively charged ions, that is called anions. Okay, so here you see chlorine gains 1 electron because it is having 2, 8, 7, so it becomes Cl minus, that is chloride ion. Oxygen configuration is 2, 6, it gained 2 electron and form O2 minus. Nitrogen 2, 5, it gains 3 electron and become nitride ion, that is N3 minus ion. Next we will see the stable electronic configuration. So why an atom is stable or unstable? So noble gases have stable electronic configuration. Why? See, helium is having 2 electrons, and other noble gases are having 8 electrons in their outermost shell. So if their valence shell is complete, then they are stable. But unstable, what happens? In unstable electronic configuration, their valence shell is incomplete, means what is their maximum capacity? They are not getting that, then it will be unstable. And what is their maximum capacity? If they get that, then it will be stable. Okay, so they tend to attain stable electronic configuration of the nearest inert gas by gaining or losing electrons or by sharing electrons. Okay, so now, so when the atoms are unstable, they combine with each other to form stable. Okay, so how they can combine? Let us see. So combining atoms redistribute their electrons so that they combine atoms attains and stable electronic configuration of the nearest noble gas. Okay, so this can be done how? This can be done by electron transfer. So they transfer the electrons, okay, which is called as electrovalency. Okay, so here you can take the example. You see, in case of sodium there are 1 electron in the outermost shell, and in case of chlorine there are 7 electrons in the, so configuration of sodium is how many? 2, 8, 1, and chlorine is 2, 8, 7. So sodium loses 1 electron, and so now sodium has become 2, 8, and chlorine has become 2, 8, 8. So both have become stable. So sodium Na plus combine with Cl minus and form NaCl molecule. So they are very stable now. Another example we can take. So here sodium was metal and chlorine was non-metal. But if both are non-metal, then what will happen? So here you see oxygen is non-metal. So there are how many 6 electrons are there in the outermost shell, that is 2, 8, 6, and here also it is 2, 8, 6. So what they do? They share 2 electrons each, and now both have become octet. You see 2 plus 4 plus 2, 8. Here also 2 plus 4 plus 2, 8. So both have become octet now. So now it is stable. Okay students, you complete the exercise of this chapter, and whatever doubt you get, you can ask me in the comment box or in the private WhatsApp message. Thank you for watching.